Thank you, Tony. I hope everyone had a decent and nice lunch. I kind of skipped it because I was a bit nervous about my presentation. I just got to be very honest here. I'm a PhD researcher with the University of Greenwich, and I was here during the user conference last year, and I was quite impressed what simulation could do, and I tried to incorporate simulation in my research work. My research work involves understanding the interdynamics between critical success factors in make-to-order small and medium-scale companies during ERP implementations. Now, critical success factors are factors which determine whether a project can be successful or was successful. Make-to-order is a strategy in which production only begins, or any design work only begins, when a confirmed order has been received. SMEs are a type of organization. Primarily, they depend upon staff numbers. What I'm looking at is between up to 49 numbers. And ERP systems are often mistakenly considered as computer systems. I believe they are continuous projects. During the course of this presentation, I'll explain you more on that. My research work is based on an SME where I work as a knowledge transfer associate. The company in question is Priorclave Limited. The company manufactures autoclaves. These are used in laboratories, and they are between from 40 to 2,000 liter capacity. Currently, the company is a UK market leader in this product, and typical volumes range between 200 to 220 machines. It's quite active both in the UK as well as export markets, exposed to over 100 countries. The strategic goal of the firm is to double its production in the next 2 years. So why are companies like Priorclave important? Companies like Priorclave are important because they constitute about 99.2% of enterprises in the UK private sector. They contribute about 48% in terms of the annual turnover in the UK private sector. They contribute about 59% to the employment statistics. And more important, with respect to my research, they account to about 57% of UK manufacturing. Having given you a background of where my work is located and what I'm trying to do, I'd like to take you through the core of this presentation. During this presentation, I'll briefly look at ERP systems, what they are. We'll look at critical success factors, how they interplay during ERP projects. We also look at the simulation methodology used in this work, and finally, results. ERP system stands for Enterprise Resource Planning Systems, often mistaken as computer systems or information management systems. In reality, they encompass the processes within an organization. A business never stays static, it evolves, so these processes also evolve. Hence, these systems evolve. That's why I said they are continuous projects. Of late, markets in large enterprises have saturated. ERP vendors or developers have started focusing on small and medium-scale enterprises since mid-2000s. What you see in the market today is availability of low-cost ERP packages, pretty much based on the ones which were made for the large organizations. And this has an issue with regards to generalization, the idea that what is good for large companies is good for small companies henceforth. Also, there's an issue that critical success factors are not well defined. This is further exemplified in my next slide, where in a recent survey of about 1,600 ERP implementation projects, it was realized that almost 57% of these projects went over time, almost 54% of these projects went over budget, and 41% of these projects failed to realize any benefit. Thus, research in ERP implementation is imperative. Having looked at ERP systems, I now would like to take you through the critical success factors which play a crucial role during such projects. My literature review revealed about 33 critical success factors. They are often very subjective. Some of them, like shown in this particular slide, like cultural issues or team cooperation. It's very difficult to quantify these things. So they are very subjective and depend upon a particular project and a particular stage. Also, the research literature review identified that production strategy plays a very crucial role in make-to-order small and medium-scale enterprises. And the literature review concluded that if a firm is able to manage these critical success factors along with production strategy, probably they have a higher probability of implementing a successful ERP system. This led to selection of a methodology in which you could analyze these CSFs and production strategy, and simulation was selected as a tool. Simulation has been identified as one of the top 10 strategic technologies a firm can adopt. This was as per Gartner's 2011 survey. In my study, I used simulation to study the CSFs in different ERP implementation phases as well as the production strategy. This was based on the IDEFO methodology, or integrated definition for functional modeling. Primarily it has 4 parameters. You got a set of inputs. Inputs could be a critical success factor, could be production strategy, etc. You got controls. Controls are the standard operating procedures or rules or regulations within a particular department or the company as a whole. You got mechanism. This could be people who actually do those roles or any other resources. And you got a set of outputs from that particular function or process. My simulation work is classified into 2 areas. We first look at simulation study 1. This was primarily related to production strategy. ERP data, which was a system which has been implemented at Priorclave. It's an ongoing implementation program for the last 2 years. Data was collected from the ERP, and simulation platform was used to analyze production strategy. This data was collected for a period of over 2 years, and it's been analyzed. And one of the key requirements of this study was that it should reflect real-time shop floor status. In this model, we used basic witness functionalities like part files. Part files follow the witness structure, which is shown here. What this allows us is that if the end user edits the date of a particular order in the ERP system, you could change the sequence of how these parts come into the model. For example, order number 10,000,010, although came after order number 10,000,003, but because it's got a higher priority, as the end user changed the dates in the ERP system, that's the way these part files or these parts arrive into the model. Also, Crystal reports, an industry standard for report writing, an add-on was used to create these part files automatically from the ERP system. So these reports are run at regular intervals, and the part file as per witness format is output of these processes. Also, variable cycle time and costs were statistically analyzed, and goodness of fit analogy was used here. I can show you an example of that in this particular slide. This is for a particular product group. The normal distribution was the way in which these products were completed or manufactured, and the goodness of fit analysis was done to confirm that normal distribution is the most valid distribution. The ability of using part files in Excel, as it was highlighted in the earlier presentations by Nathan, is that it gives the end user a lot of flexibility to use Excel files. A lot of end users who have not used simulation before have known skills in using Excel files and can use such systems. They can edit labor. Say if a given operator is not available for a particular task, then that could be corrected, and this then reflects back on the system. Say for a particular, as I said, if say operator number 3 is not available, the end user can make those changes in the Excel file, and this is then put back into the system. They can also edit the priority, which I showed you via part files. They could also edit the material. Now, often in SMEs, we often have realized that the stock in the ERP system doesn't actually match what is there on the shop floor. The stock control is not that stringent or tight. So what this allows the end user is they can actually, reflecting on the shop floor status, they can edit the material also. Also, they could edit cycle time. And this is particularly true because there are a lot of manual processes in small and medium scale companies. A particular operator might do a particular task in a given time, but that may not be the case for a different operator. The second study was about studying the critical success factors and the interdynamics they play during ERP project implementation. Over the given period of 2 years in which the company has decided to go for the ERP system, the project has gone to a great extent as per plan. The company has realized some benefits in a lot of processes. Also, there have been areas where it has not yet realized any benefit. But what was noticed is that CSFs are very subjective, and for an implementer or a project team, it is very important that they are able to reflect the real-time status of a critical success factor during the implementation process. Again, simulation platform was used, and IDEFO methodology, which I showed a little while back, was used. In this case, I can show you one particular customization we did during the adaptation stage. This was related to generating an internet calendar, an iCal, using the ERP data, and then feeding this data into smartphones of engineers. So you got a set of inputs. This could be different critical success factors. You got control. Control could be the service order entered in the ERP system or the purchase order number received from the customer. You got mechanism. These are, in this case, it was the service staff who actually played the role of the mechanism factor here. And you got output. The output is the service engineer gets the list of jobs or tasks they need to do for a given day or a given week. And this has helped us to take care of the whole process from job initialization to closure and enable to fasten the invoicing aspect of it. Another aspect which I have noticed in SMEs is that SMEs do not have enough expertise in terms of estimation of a particular task, estimation of what resources are required or how much time it's going to take. One of the valid methodologies which could be used, and it is a proven project management methodology, is Delphi analysis, wherein the project team, depending upon a given stage or a given task they are trying to implement, would have estimates for resource or task. And it's an iterative process. You go with one particular iteration, and then depending upon that, how correct the estimates are or how close the estimates are, you would then carry on this process further. Again, like the production strategy methodology, witness part files and Excel files were used in this case also. The model takes care of CSF attributes like the stages of an ERP project. ERP projects could be classified into 5 stages. Primarily initialization, adoption, adaptation, routine, and retirement. Although retirement is a phase a lot of firms have not yet reached, most of them are in either adaptation or routine stage. Also, they could take care of the sequence in which the CSFs come into play. Because it's subjective, because of Delphi analysis, end users can see the priority in which they want the CSFs to come into the model. Also, time is taken care into account, by which time a particular CSF would be available. That is also taken into account. Also, cost is another factor which is built into the model. And you also could simulate implementation team, which is another sort of resource which you could simulate using this model. With regards to results, I primarily did 10 runs for both these models. I used both random and antithetic numbers. It helped me to ensure the reliability and the repeatability of my model. The results for the production strategy showed that the end user was able to overcome the inability of ERP systems to help in making real-time decisions. This feeds into the customer relationship management of the ERP add-on, wherein, especially with regards to lead time of a particular product, the model helps in determining that factor and helps the end user make a more educated decision. Also, it re-emphasized what was found in my literature review, that production strategy plays a very important role in ERP implementation in a make-to-order small and medium-scale manufacturing company. Just would like to show you the layout of the model. Sorry if you may not be able to see that as clearly, but what you have is the one in the blue fonts are the various part files. The company primarily makes about 6 families of products. So each is related to that product depending upon how it's entered in the ERP system, and they come according to priority. I use a lot of tags. Tags is to show visually that which particular order is going through, or the user can look at it and kind of visually see which particular component is being made. Labor has been input into the system. This is done by Excel file. The user can also take care of the cost and time factor of it. And also it visually tells by which month the particular order would be completed depending upon all these attributes. The CSF experiment results showed that the end user can visualize the dynamics between the different critical success factors for a particular project or a particular stage. It helps to address research gap, which was identified in my literature review. Also, it helps SMEs to determine the time and costs for future events during such implementation projects. The outlay of this model is similar to the production strategy model. Again, user part files, the ones in the blue font. These stages have been classified as initialization, adoption, adaption, routine, and retirement. And you have both the team, which is modeled as labor, and again, use of tags and cost and time related to the CSFs. So where is my work heading to? Literature review further identified that in make-to-order environment, workload control, or WLC logic, has some promise. This was something Nathan also said in the beginning in terms of that mean throughput is directly proportional to mean work in progress. And the crucial decision over here is that the release decision of a job, that is the most crucial decision which underpins this rule or this law. And I believe that the simulation model would help the end user to make that decision, that release decision, when to release a particular work. Also, I would like to test the robustness of my model with data from a different MTO manufacturer to check the reliability of the critical success factor model. To summarize, I just would like to say that SMEs can adopt simulation. I think critical success factors and their interrelations play a very crucial role during ERP implementation, and they're very subjective. So it is very different for each project. I also believe that production strategy in make-to-order manufacturing is a very important critical success factor, and one needs to manage that to manage an ERP project. And finally, I use simulation to study the interrelationships between both these phenomena, CSFs as well as production strategy. Thank you for listening. Any questions, please?